What's up, team? Today we're going to talk about a whole bunch of rules of exponents. Some of these you've seen before, some of these are going to be new. I'm working from this foldable here, and I'm going to touch on all 8 of these. I'm doing them in the same order, but not in the same format. My board is just shaped differently than this piece of paper, so you can use this to follow along. And what I have here is I use the exact same titles that are on this foldable, and then in black underneath it, I have the rule itself, just like it is on the foldable. And then I'm going to go through some examples that I've written up here in blue. So blue are the examples for each of these. What's in black is what you already have on the foldable, or it's the rule themselves. If you don't have the foldable, capture the rules in black. They're the rules that are always going to be true, and they're written in general form with A's, with B's, and with X's. Okay, so this invisible power rule it's trivial. It's one of those like, oh, duh type of things, but it's still worth mentioning because it comes into play. Sometimes we accidentally forget that it's true. So in general, x is the same thing as x to the first power. So with this example, what I'm going for here when I say 15 equals, I just want to point out the fact that it's the same thing as 15 to the first power. It doesn't change the value, but sometimes it applies, sometimes it makes a difference. Okay, then we have this here, x squared times y times z to the 15th power. What I want to point out with this example is that that's the same thing as x squared times y to the first power times 15. This comes into play working later on with the product rule. Like say you have an a value of 1 and then you just forget to do that 1. So I want to make sure that we recognize that. If you just have a variable by itself, it's the same thing as having a variable to the first power. Okay, product rule. A to the x power times x to the a power times x to the b power equals x to the a plus b power. We've discussed this previously, but as an example, x to the 12th power times x to the 3rd power, well, they have the same base, it's x. I don't know what x is, and I don't care what it is. What I care about is the fact that they are the same. From this, we can just add these exponents together. And I talked about why that's the case in the previous video, so check that out. And 12 plus 3, of course, is 15. So this ends up being x to the 15th power. Okay, same is true if you have bases that aren't x's. So here I have 5 squared times 5 to the 10th. Same base, in this case, it's 5. Now we add the exponents. 2 plus 10 is 12. Now we could take this a step further. I don't know what 5 to the 12th power is. You can throw it in a calculator and figure that out. Okay, power rule. This one we've touched on. It's really just a variation of the product rule, but there's an additional shortcut to the shortcut, which is kind of fun. So here, the rule itself says x to the a power. If that whole thing is also raised to the b power, you can just multiply a times b. So x to the a to the b power is the same thing as x to the a times b power. And I know that sounds really clunky and complicated, but in practice, it's not so bad. So as an example here, x to the 3rd power is squared. Notice the whole thing is being squared. This says that we can just multiply 3 times 2. So this ends up being x to the 6th power. I've heard these called before. I've heard these called piggyback powers. Piggyback powers. Maybe you like that, maybe you don't. Okay, now here we have 4 squared to the 5th power. That is 2 times 5 is 10. So that's 4 to the 10th power. And again, we could simplify that by doing 4 to the 10th power. You can grab your calculator and make that happen. Please don't make the mistake of doing 4 times 10. That is not 4 times 10. Next, power of a product. So we have a product in parentheses this time, and that product is being raised to a power. Notice the difference. Here, you have some base raised to an exponent, then that whole thing is raised to an additional exponent. Here, there's a product, 2 things being multiplied by each other, and that is being raised to some exponent, a in this case. The result here is just x to the a power times y to the a power. So you just bring that a power in. It's kind of like a distribution, sort of, kind of. So the way we could use it here is if we have xy to the power of 4, that's just x to the 4th times y to the 4th. Here's a more concrete example. Here we have 3 times x cubed times y, and that whole thing is being raised to the 2nd power. So we're gonna do it chunk by chunk. Here, so we have 3 squared, which of course is 9. And then you have x, well, here we're actually applying the power rule as well. So you have x cubed squared, so that's x, and then 3 times 2 is 6. And then you have this y, and remember that's y to the 1st power. We're applying that invisible power rule now. 1 times 2 is just 2. So this is a simplified version. Again, we can take it one step further because 3 squared is indeed 9. I just ran out of space. Zero exponent rule, we've discussed this previously as well, and there's a whole demonstration as to why this is true. So here's a refresher as what the rule is, but not the why. Check the other video for that. X to the 0th power is 1. X can be anything, literally anything. It can be 100. 100 to the 0th power, 1. What if you have 10 million divided by the square root of pi, and that whole thing is raised to the 0th power? It's 1. It doesn't matter what is in this business here. As long as the whole thing is being raised to the 0th power, the result is 1. And again, I explained that previously in another video. Quotient rule, x to the a power divided by x to the b power. This is where we just subtract the exponents. It's x to the a minus b power. So notice that they have the same base. In this case, it's x, and it only works if they have the same base. If there's an x and a y, or an x and a something else, then it doesn't work. But in this case, they have the same base. So this ends up being just x to the 10 minus 6 power. 10 minus 6 is 4. Same thing going on here, 5. But now we need to do the 7 minus 2. 7 minus 2, I believe, is 5. So it's 5 to the 5th power. We could take that a step further, but just for the sake of time, not going to. 2 to go. Negative exponent rule, discussed this previously as well. X to the negative a power is 1 over x to the a power. So basically what you do to make the exponent positive is you send it to the bottom or the denominator, so the bottom of the fraction or the denominator, or you just invert it, because remember this is the same thing as putting it over 1. So you flip it and you can make the exponent positive. So here if you have x to the negative 3rd power, that's the same thing as 1 over x cubed. And then this next one, we have 11 to the negative 2nd power. That's the same thing as 1 over 11 squared. And you can take that a touch further, 1 over 121. Lastly, power of a quotient. So a quotient is the result of a division problem. So we have a division problem, x divided by y. That whole thing is being raised to the 8th power. The rule here says that equals x to the a divided by y to the a. So again, it's kind of sort of like a distribution type of thing. You can bring the a into the top, bring the a into the bottom. So here, concrete example, x divided by y, all raised to the 5th power. That is x to the 5th power divided by y to the 5th power. And our very last one, same rule, a little bit clunkier. So in the numerator, we have 9x cubed. The denominator, we have z. And we're just going to bring that 2 into each piece. So we're kind of applying, which rule was it? The power of a product rule here as well, because this is 9 times x cubed. So this ends up being 9 squared, because if you bring this business in here, again, it's kind of sort of like distribution, not exactly. And then we're going to apply the power rule as well. So x cubed squared is x to the 6th, because 3 times 2 is 6. The denominator, we just have a z to the 1st power. So here we are applying the invisible power rule. And then 1 times 2, that's just 2. So this ends up being z squared. So 9 squared times x to the 6th power, all divided by z to the 2nd power, or z squared. Again, to simplify this a little bit further, do the 9 squared, it ends up being 81. Okay, here are 8 rules of exponents that are in your foldable. And if they're not, make sure to capture them. Everything you need is here. These, like you saw at the end here, most times you're simplifying expressions or whatever. It's not going to be just cut and dry. It's going to be multiple of these pieces, and you're not going to know, you're not going to be told, hey, use the product rule to do da 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 da. It's going to be like, hey, here's a gross, messy expression. Use one or more of these tools and simplify. So it's going to take some practice. It's not a straight step-by-step situation. Sometimes you use one rule, and then that will force you to use another rule, and somebody else might do it in another order, and that's okay. There's lots of correct ways to make this happen. Okay, rules of exponents. Dive into some practice problems. You got this.